So we talked about naming conventions so far, then we talked about classes and kinds of types, and now we're drilling into the next level of detail and talking about members. And these members can be applied to any kind of type that we've talked about. So the goal of this one is to give you the kind of pros and cons, or when to use each kind of type and each kind of member and the trade-offs associated with them. So what we're going to talk about is constructors, methods, fields, properties, and events. So we're going to go through each one of these and talk about when they should be used and not used. Okay, so constructors. So you should do minimal work in your constructors. The goal of the constructor is to capture those arguments for later use and then be done. The idea, the kind of philosophy behind that is the deferred execution. That you sort of have two options with your constructor. You could go and do a bunch of upfront work such that that work's already done, and when you do the operations, it'll be cheaper. But the problem with that rationale, as a general rule, is that sometimes you may construct the object and then never use it, and then you've wasted all that processing time. So, as a general rule, you're better off doing minimal work in the constructor. One question that I often get is it okay to throw exceptions from constructors? And the answer is absolutely. It's okay. Any of these members can throw exceptions. There was, I'm told it was mainly bugs, but it was fairly common in the C++ world that you shouldn't throw exceptions from your constructor, or the kind of destructor might not run, the instance actually didn't get allocated, and you could have some dangling references. So at least in the old days in C++, it was good enough to, it was kind of the standard practice was to not throw exceptions in constructors. And I just want to emphasize that here, it's fine to throw exceptions in constructors. The memory will still get deallocated, and your destructor or finalizer will still get run. And then just like any of these members, you should be consistent in the order and naming of parameters, constructor parameters, when you're doing an overload. And I'll talk about that. Again, in that same category we were talking about, don't accept the defaults. I'm going to say the same thing about this. The compilers will often insert a default constructor on your behalf if you don't have one. And again, this is for convenience of application developers, but it's a bad thing for you as framework developers. So I encourage you to always provide a default constructor. So every single class should have a constructor. Now, some of them might be private or protected, but you should always have one. So just give you an example, if you don't have one, C# will put one in for you, and so these two code snippets are absolutely identical in terms of the IL they generate. And the problem with that, the big problem we found, and actually this actually bit us in V1.1 of the framework in a couple of places. What happens is, I can't think of a constructor to have, so I won't have any constructor. So you don't have any constructor. And in V2, you think, oh, yeah, we could take an int and it'll do blah, blah, blah. So in V2, you add a new constructor. But now when you have that constructor, the C# compiler doesn't add the default one because you've already added one. So what that essentially means is between the two releases, you've removed the default one and added this new one. So that will break code. That's a breaking change. Anybody that was calling the default one now no longer can. So don't get yourself in that situation. Always provide a constructor of some kind. Worst case, a private default constructor. Okay, so there's this interesting relationship between constructors and properties that it's good if you can maintain, especially in your higher level classes. And that is that the arguments to the constructor should be aliases for setting properties. So this is a kind of very nitty-gritty way that you can have a scalable API. Christoph talked about kind of the opportunistic developer. And the opportunistic developer, the VB developer, likes to think about everything in terms of drag and drop. So, okay, the opportunistic developer thinks about taking a button and dragging it on a form and then running that. And maybe going over the property window and setting the text of the button and things like that. That's what they think about. So when they're writing code, what they think of is, instead of drag and dropping the button over, okay, I'm going to have to new up an event log. That's like dragging and dropping a button. And then I'm going to set a couple of properties in it. Okay, that's like going over to the property browser. So that's their mental model for it. But then if you talk to like a low-level C, C++ developer, they're like, what's the fewest number of lines I can do to do this in? I kind of operationally want to encapsulate all this into one single call to, for whatever, for performance reasons or to get good locality. And so they might like the bottom one. So now you can have a single class that has everything on the constructor, if that's what your low-level person wants to do, or call a constructor and set properties, if that's what your VB guy wants to do, and then anything in between. So it's a simple pattern that gets that. So why don't I try to get through this one, and then we'll come back and hit questions. So, okay, so talk a little bit about overloading. This is kind of one of my personal pet peeves. A lot of our developers, when we have method overloads, so we have, a method overload is methods with the same name but different signatures, different number or types of arguments. So, kind of you and I really understand that those are two method overloads, like the string, the index of that takes a string and index of that takes a char array, are absolutely two different overloads. The runtime has zero association between them. You look in the metadata, they're totally different. At every call site, you can tell exactly which one you're calling it. They are completely different methods from night and day. But the problem is a good chunk of our developers think of those as being the same method. Yeah, you have an index of method, and it has a couple of flavors to it, right? That's how a lot of the VB developers think about the world. And frankly, they're coming from a rational place. That if you're giving methods the same name, they must have some inherent kind of cohesion to them. In fact, I had a chance to interact with Bertrand Meyer on this issue. Does anybody know Bertrand Meyer? Fairly famous guy for doing the Eiffel programming language, and he's very well known in the component development community. And he feels, and in fact, he argued for quite some length to ban method overloading from the CLS for this reason, because he doesn't believe that we can actually do a good job of making sure methods with the same name actually do the same kind of thing. They're actually part of the same family. So he would certainly rather this not be allowed in the CLS. And frankly, he's got some merit to it, but the convenience of this, I think, far outweighs the cost that he's outlining. But anyway, that's just to say that you should treat these families of methods as doing the same thing. And we got bit by it in this example of in index of. We were actually standardizing the string class as part of the ECMA standard. And in that meeting, the guy that was from Fujitsu doing the COBOL compiler, they were actually doing some tests. And apparently, I'm not a COBOL expert, but apparently COBOL has a rule where a char array will implicitly convert to a string. It's actually a preferred conversion. So he was actually writing in COBOL code, and he couldn't force the call to or couldn't easily force the call to the string overload when he had a char array. And that, because he had to do that, that indicated that maybe we don't have these methods are not doing the same thing. The index of that takes a string value finds the first instance of that substring anywhere in the larger string. And the other one, the any of, is a char array, and if it finds the first instance of any one of those characters. So you can see they do really radically different things, but we gave them the same name. And so that's an example of bad overloading, that they're really different things. In the end, we actually ended up calling the second one string.index of any, just to separate it apart as a different kind of method. But a good example, though, is convert. Convert has a bunch of overloads on there, and they're fine. The convert to string, one takes an int, one takes a double. They actually go down vastly different code paths internally. But semantically, what they do is similar enough that it's fine to have those be the same overload. Okay, so talk a little bit about defaults here in method overloading. It's really common to have a simple overload with no arguments or one argument, and then another overload that has a couple of more arguments, another one with more arguments. That's another one of those pay-for-play kind of things. Yeah, you can set the nth bit on the 12th data structure if you want to, but you kind of have to call the longer method to do that. You get more play, but you have to pay more in terms of the complexity. But if you just want to do something simple, there's just a simple method for it. But when you do that, you should make sure you do it in a really rational way where there's a nice kind of flow between them, and that is that the more complex, all of the simpler ones should just be aliases for calling the more complex one with default values. So the ideal case is like here, get method that doesn't take a bool all it should do is just turn around and call get method that does take a bool passing false for ignore case. And it's good to, I mean, not to put too fine a point on it, but use the defaults I've specified of 0, empty string, false, because that's a place developers think about for defaults. I mean, the alternate design we could have done here is say the second overload could be type.get method where it takes a string name, bool case sensitive. And if we had passed bool case sensitive, then the default, if we wanted to keep the same default, would have to have passed true to it. And that indicates that it's a little bit, it's not, kind of doesn't flow nicely. It's not consistent. The default is not the kind of base defaults for the system. Okay, so this is just another kind of example for how we like to do it. You see the bar method with no arguments, just passing the defaults to the bar that takes one argument, and then finally the last one. And notice the last one, that's the one that should be virtual or not. Like, there's no reason to make the others virtual because they all call through to the more complex one. People subclassing your type, it's fine to give them only the more complex one to customize. And we'll talk about that more when we do the subclassing discussion. Okay, so params. Params are the CLR answer to variable arguments. C has variable arguments. And so we use params for that. And what it is you decorate an array in an argument. You say, this is params, and that gives a hint to the compiler that at the call site, it doesn't require the user to type in the actual new array, blah, blah, blah. You can actually type in literal values right there. So I don't think it's super common, but interesting. Okay, so one little bit on performance here around methods. For a variety of reasons, I think it's good to minimize the number of virtual methods you call, the really large methods, and really large number of locals. So all those, I think, just good software engineering principles, I could argue, that have nothing to do with performance. If you call too many virtuals, any one of those virtuals could call back into user code and could become a problem, so you have to code defensively around those. Writing really large methods or methods with lots of locals, just software engineering is probably not a good principle in terms of code maintenance. But in addition, there's some performance issues with those things because what the JIT likes to do is be able to inline the calls. So that is, if I'm JITting one assembly, I see that it calls these simple methods from this other assembly, I can just bring that code, I can JIT those and then bring that code into the first assembly. So then I don't even have to call that, don't have to do a cross-assembly call there. So the JIT likes to inline them, and it can do it if the methods are kind of more simple in nature. Again, it's not something I think you have to worry about on a day-to-day basis, but if there's this particular piece of code that you know from looking at profile logs is a big issue, you might want to investigate some of this. Okay, so fields. So my general rule with fields is to avoid public instance fields, and that's because you give up, it's so cheap to use properties, and with fields, you give up so much control. With fields, you're kind of you're exposing your internal implementation to the user and kind of giving up your freedom to change that in the future or modify it in any way. We actually had an example where in V1 we had this debate. We said, oh yeah, we'll never need change notification or caching or something on that. So we just made them fields, and then sure enough, it was only one release later that we said, oh wow, gosh, it would be so nice if we could do some kind of notification when that value gets set. So we were kicking ourselves that we didn't provide properties such that it would give us some flexibility to add those in the future. So I encourage you to just avoid using public instance fields in 99% of the cases and use properties. It's a little bit more code for you, the developer, to write this version, but I believe it'll pay off for you in the long term. And the point I'm just bringing out here is that the performance cost of properties is very insignificant. If all you do is say return your internal field, then that'll get inline and it'll go away. So maybe let me just finish and we can get questions. But do remember, because I do want to get them. For static fields, static fields oftentimes are more, there's less chance of needing to change those or get notifications. So although static properties are great and you still may want to use them, I don't feel quite as strongly as I do about instance fields around those. So I alluded when we talked about enums a little about const versus read-only, but let me just spell that out really clearly around fields. So const, what it is it's compile time evaluated, and what happens is when you have a const field, you'll notice that the compiler actually just, whenever I call that const field or ask for that const field's value from another assembly, instead of putting that field name in there, the compiler just says, oh, 42? Okay, and it puts the literal 42 in your program. And that's great. It's a performance thing. But if you ever needed to change that value, then you would have a trouble. So you should be very careful with const and only use it for places where you are absolutely sure it's some kind of universal constant of the world that is never going to change. So that's const thing. And then the read-only thing we talked about a little bit, it's the same kind of thing except for it's runtime evaluated. In the same case I talked about, if it was a read-only field, then what would happen is you would actually put a reference to that field, and at runtime you'd evaluate it and suck that value down. So that gives you more degrees of freedom to change that in the future. Okay, so properties. Properties are like smart fields is what I call them. They're just a way to put some sugar around fields. And they're calling, it's beautiful, their calling syntax is exactly like that of fields, but their implementation is exactly like that of methods. So I think it gives you the best of both worlds there. But, you know, like any tool, the tool can be misused. I think properties is one of the more abusable features we have. So just give you a couple of pieces of advice on it. One is you can have read-only properties. It's one of the great things. You can't really have, read-only fields kind of work, but read-only properties work much better. You don't want to have write-only. You can technically have write-only properties, but it's kind of a weird concept to want to do that, and it will throw developers for a loop. You might, if you actually have some kind of write-only nature, I think a method might be better. Properties are good because you can raise property change events and things like that. That's especially important when you're in some kind of UI or complex framework. Properties give you that ability. Property getters, you should focus. See, properties have this problem where because they're like methods, people are like, well, wow, I can type any line of code in here just like I could a method. That's true, but developers have some kind of expectation about what a property get's going to do. And they think of a property get like a very simple operation of returning a field. So although you might do more than that under the covers, it would be better if you modeled it that way. So it should be a little simpler and is therefore unlikely to throw exceptions. properties should be very independent of each other. So I should be able to set my properties in absolutely any order I want to set them in. You shouldn't enforce any of that. If there is some ordering involved, then you need to use a method instead. Right. So one of the very common things we hear is that properties, I want to have a public getter and a private setter. So C# is actually adding support for that feature in WIDB that you're welcome to use. But then the next thing you often ask for is, okay, I want a public setter, a public getter, and a protected setter. Now the difference with that is both of those are probably your public interface and therefore subject to the CLS rules. And the CLS today doesn't allow those to be different. The accessibility of all the accessors have to be the same for the CLS. So but actually I think it's fine. That the pattern's fairly simple to work around, and this is the pattern for that. Okay, so I'm going to walk through a little bit of the when to use properties, when to use methods thing. We've touched on a few of these, but just to spell it out. You should use properties if the thing you're trying to model is logically the backing store is logically modeled as a backing store, then properties are fine. So for example, type, system.type has a property on it called name. Well, the truth is there's no private field in type called name. The name of the type is buried somewhere in some metadata table deep down the E. We have to go kind of pull that crap out and parse it and return it to you. But that's fine. It's actually some work involved in doing that, but it's okay because it matches the user's expectation. The user thinks about there as being a name associated with the property. On the other hand, though, we have this GUID class, and it has this get next GUID method. Well, we in our zeal to add properties to the system, we just say, oh, everything that begins with get, just make that a property. And so we change the get next property on GUID, which generates the next sequence GUID. Like sometimes for debugging purposes, it's interesting to have GUIDs that are consecutive, so they sort together in the registry or whatever. They're not actually unique if you do that, I guess, but we have this method anyway, and so we just changed it to be a next property. And then we were using it, and we were saying, wow, GUID.next. Well, GUIDs don't naturally have this kind of property that's their next one. I mean, there's an operation you can perform on a GUID to generate its next one, but there's no sort of natural property there. So you should use a method. You should use a method if it's a conversion. So don't use properties for conversions. We played with that a little bit. It doesn't work very well. If the getter does some kind of observable side effect, if you can tell if by calling this getter it actually changes the state of some other stuff that's observable, then you should probably just use a method for that. If what you do is refresh a cache or something like that that's not observable, then that's fine. I talked about it already, but if order of execution is important, so if I call this property, and this property, I get a different result than if I call that one, this one, and that one, then you need to use a method for that instead. And then the next one is admittedly fuzzy, but if it might not return immediately. So the model with a property is it's a field access, and if you're several orders of magnitude more than a field access, then probably a property is not a good idea. So I think the easiest way to figure that out is if you would be debating doing an asynchronous version, if somebody is even asking, should we have an async version of this? If someone even asks the question, then you should definitely be having a method instead of a property. Because if the operation is so slow that you would want to have some way to do it asynchronously, then it's definitely too slow for a property. And some of the guidance, we dreamed up in consistency land, and we kind of figured out what we're going to do and just laid it out. And some of these we learned from the School of Hard Knocks. We learned by doing it and messing it up and then coming up with a guidance. So this is that case. We actually ran into this in the actual implementation of the framework itself. What happened is we had some properties that returned arrays. And so what happens is on this collection called employee list, it had this all property. And what the all property does is it takes the internal list and it clones it. It copies all the elements and returns that as a new array. That's useful if you wanted to get a snapshot of the thing. But it was a property. And so what ends up happening here is that somebody's for eaching through this collection, or has a for loop through this collection. And what they should do is they should do L bracket I bracket and call it the indexer. That's kind of the intended way to do it. But they miss that. That's natural. They could miss that. And they see this all property. Oh, great. Oh, L.all. Okay. And then, oh, they see it has an indexer, and they call that. And now each time through the loop, what's happening is they're calling the all. It's snapshotting the entire array. They're plucking one element out and throwing the array away. And then next time through, snapshot the entire array, plug the next one out, throw the rest away. So they do that kind of n times, where n is the length of the collection. Now we have a great garbage collector; it works beautifully. But something like that, I think, can push us over the edge. So I actually don't so much blame the poor guy that wrote this code, because I blame the person that wrote employee list, because employee list, those people didn't follow the guidance that properties shouldn't return arrays. Because if they had followed the guidance, then they would have, then the person writing the for loop here would have had to have written the if statement in the call out box that looks like this. They would have had to say L.getAll, open paren, close paren, bracket I. Now that looks like an expensive operation to me. If you're doing a code review and you see code that looks like that, that sets off bells and whistles for you. That's where you kind of have a talk with the developer and discuss that in a little bit more depth as to why they're doing that. Whereas the other line looks natural, it could work. So the lesson here is to make sure that if the member is going to return a snapshot, if it's going to do that kind of snapshotting operation, then it should really be a method. Okay. So properties can also have indexers. So properties can also have indexers, and that should be where the logical backing store is an array. And the indexers, although they could be absolutely anything in the system, you're better off using object, int, and string, things that are more natural kind of indexing kind of types. And the other thing is sort of rare to have multiple indices. We reviewed some APIs recently where the indexer took a string and 2 booleans to the indexer. I was like, that's a little bit bizarre. I mean, you're saying you have this 3-dimensional array indexed by bool. It was a very bizarre thing. Turns out that, it was just fine to do that thing with a method. And that made more sense to the users. So, okay, sorry. So events. So defining an event. Events have 3 parts. You have the event handler, and that's a delegate. That the delegate represents the contract for a method. It describes a method signature that can receive the event. So the delegate is describes the method signature, and then on the actual class, you have the actual event itself. So in this case, the click event. And the click event specifies the event handler, or the kind of method that can receive that notification. The kind of method that takes a object sender or event args e. And then the onClick method. And the onClick method is a way to explicitly kick the system to make it generate that click event. Instead of the user having to actually click the button, you might want to do it programmatically. So those are the 3 parts of an event. And then use an event is easy. You sign up for the event using the delegate syntax of adding a new event handler and associating the name of a method that matches the event handler's signature. So in this case, button click takes object sender, event args. Okay, that's event 101. So some terminology thing. Events are, we talk about events as being raised as opposed to triggered or fired. Employees are fired, events are raised. So So you remember that as you do documentation or whatever. So you should name events with a verb. They're action things. And event handlers, you always want those to have void return types. That enables more than one event handler to sign up there. Okay. You notice the event handler guy, it always goes object sender, comma, event args. And if you think about it for a second, it's kind of a little bit bizarre. In the method section, I didn't say encapsulate all your parameters into a structure and then return that, or a class and return that. But we do here. And the reason we do here is because the event args guy, you should have a subclass of event args that encapsulates all your arguments. So all of your event handlers should only take object and then subclass of event args. And that's because if you want to add a new piece of data you find some new data you want to pass to your event guys, if you have to add a new argument to the delegate, then you have to have a new event handler, which means you need a new event, which means everybody that signed up for your event won't get it. They have to define a new method that handles that event. So it gets to be a real mess. Whereas if you have the event handler, you can just start returning that new data, and then clients can incrementally, as they decide to, start taking advantage of that data. So it's kind of a versioning compromise. Okay. So as I mentioned, you should provide some protected method to raise the event on on event name, for example. And then it may need to be virtual if you want people to subclass to be able to override that thing.
Is there any good way to document the order of the args?
Is there any good way to document the order of the args?
Yeah, if you're just adding them on and somebody like subclasses and changes the order or whatever.
Well, the order of the arguments I mean, the runtime it's a dynamic layout thing, so the order in a class, the layout of fields in a class don't matter. Does that answer your question? Let's talk. Let me almost through here. Let me press through here. So one thing to remember: whenever you're calling an event, whenever you're raising the event, firing it. No, I'm just kidding. Whenever you're raising the event, you need to be aware that you're calling into arbitrary user code that could do anything. Now, of course, you should spell out in the documentation what people are supposed to do and not supposed to do, but it could do anything. So you have to code defensively. And that means you may want to put a try finally around your calls to raise the event, because that guy could throw an exception. He could throw any exception. You may want to make sure that after you call the event, you're actually defensive in terms of, one thing they could have done in that event is they could have closed the window handle underneath you. So some of the assertions that you believe to be true may not be true anymore when you come back from that. Okay, so just to real briefly on static methods, any kind of member can be static. Everything we talked about, constructors, properties, events, all those can be static. Methods, obviously, and the basics on statics is you can't access instant state because you're static. You can't be overridden or specialized, so there's no customization with static methods per se. And you generally must be thread safe if you're static. It's generally a good idea to be thread safe because the programming models can isolate thread safety requirements, so you don't have to have all your instance members to be thread safe. That would be very onerous. But static members, it's much harder for the application models to isolate that. And these are commonly used for factory methods, the singleton pattern, and utility methods. We'll talk a little bit about them. So I like to think of these guys as pretty much the equivalent of global methods. And if you remember global data members. If you remember your kind of software design 101 class, you know that global variables are kind of the root of all evil, right? You're supposed to avoid global variables. Well, okay, the same kinds of pros and cons go with static fields. They're essentially global, where anyone can access the state, which is great, but can also be a problem. So I think that they're useful where where a full modeling of the system may not be required or may be overkill and actually defeat simplicity. So I think system.math is an example of that. It's a bunch of static methods. You could imagine modeling it as a set of abstract operations over enumerands and whatever, but that would just be way overkill for what we're trying to accomplish. So static members are also good for what I call the singleton pattern. And this is where you have one and only one instance of a given type. And static methods make it very easy to accomplish that. So I will point out it's not exactly the gang of four pattern. And if we get time towards the end, we can talk about exactly why it's not. But it's essentially the gang of four pattern says that the value is not allocated until it's asked for the first time. But with this pattern, the value is allocated the first time the class is touched. It's first time DB null is touched, the static constructor will be run, and that value will be allocated. So in practice, there's no difference, but there's just a kind of small subtlety. Okay, so parameter passing. So we've talked about all these members, and now we're down into parameters. Value types. So we have two kinds of things. We have value types and reference types. And then either one of those can be passed by value or reference. So you can have value types by value types by reference types by value, and reference types by reference. Confused yet? Okay, so we're going to walk through each one of those and talk about what does it mean and how useful is it in terms of API design. So the first one, a value type by value, is the default thing for value types. It just copies the value as we talked about with no side effects, and it's a very commonly used thing. The second thing is a value type by reference, and a value type by reference passes a pointer to the thing. So this is what we do with try parse, for example. We actually pass a pointer to the place where that it value is stored, and that does allow side effecting. So this is the case where there's certainly some utility to it, but overall you should be careful. In fact, I am 100% convinced you can build a very workable system without any of this kind of usage of reference types. I mean, for example, Java was able to build this very extensive system without any usage of this. So I think you should be fairly constrained in your usage of it. And then you can have reference types passed by reference, and that's the common way. Reference types passed by value. Reference type passed by value is the common way to pass reference types. You're passing the reference itself by value, not what the reference is pointing to, and that's the common thing to do. And then the last one is the most bizarre. I couldn't even come up with an example for where we've actually used it, and that's a reference type passed by reference. So reference type, you're already passing the pointer, and now you're passing a pointer to the pointer. I think that's fairly bizarre and should generally be avoided. Okay, so talk a little bit about ref and out. These are C# keywords. Ref means it is in out, and out is out only. And the difference, really, the runtime doesn't know any difference. It's mainly a convenience for C# developers around whether a variable has to be definitely assigned before it comes in or not. And my general rule is they're great for interop scenarios. It's a fine thing there, use them to your heart's content, but be suspicious about their uses in public APIs. And I'll give an example here. A gratuitous example, I'm sure you could pick on it, but there's a couple of ways to model a get location. You might do a get location where you pass in an X and a Y and I fill it, or you could do get location that returns a struct with X and Y in it. And I argue for this, the second is a lot more usable than the first. That's my general rule there. So, obviously anything taken to extremes is bad, but as a general rule, Win32 used a lot of these what are equivalent of these reference types. And I want us to be a little more cautious about how we're using them and use them in more constrained scenarios. Okay, so earlier we talked about argument validation. I think it's an important thing for members. We do, for all your publicly exposed members, so that's public and protected, you need to validate the arguments when they come in. So that catches errors early. It's much easier for developers to debug and use the code. In fact, you know, I've argued with people before about you pass in this instance, and I want them to check to make sure the instance they passed in is not null, and then do all the operations. And the dev's like, well, yeah, but if I don't do the check, the runtime will do the check for me and will throw a null reference exception. And that's true. The runtime will throw a null reference exception. But then look at the user experience for the guy using your code. The person using your code will call the method. They won't know they pass null, right? They got it from somewhere. They have some bug. They passed you null. You know, it's 3 a.m. It's due tomorrow. They've been working on it all night, and they pass you null. And then somewhere like 8 levels deep in the call stack, you finally get around to calling a member on that thing, and you get the null reference exception. So the developer's looking at the call stack, and they see 8 levels deep in Microsoft code, there was a null reference. Those frickin' Microsoft people, right? They have so many bugs in their software. You know, how come I get a null reference exception? And they get a hold of, you know, PSS and track it down. They finally figure out it was their fault. But are they any happier to know that it's their fault and that they wasted all this time? I don't think we've satisfied that customer. The other scenario is they make a mistake. They get a null reference exception immediately. They look at the call stack. They see all their code, a call to us, and then a null reference exception. And then a argument null exception, and they read the message, and it says you passed an argument foo, and argument foo cannot be null. And of course they go, oh, argument foo is not null, and then they spend some time in the debugger, and they find their bug. And they're a much more satisfied customer for you just doing a little bit of argument validation. So it's totally worth it in most cases. And it's also a powerful security boundary. One thing that I thought was really interesting, right before we shipped V1 of the framework, we did a huge security push. We actually took the entire dev team offline for 3 months and did nothing but scan code and look for issues. And one of the ones we found that I thought was great was a developer was very cute and made a enum that exactly matched a set of pound defines in the Win32 API. So there was sort of a one-to-one correspondence. Like this was, you know, -72, it would be -72 in the enum and whatever. And for whatever reason, he left off one of them that was a security issue. He said, oh, well, that's a security thing, so I'm not going to include that one in my enum. So he didn't include that in the managed version of the enum. But then some enterprising hacker noticed that that's what was going on, and that what the developer was doing is he just took the enum, didn't validate it, and passed it right to Win32. Never even looked at it, right? Because, hey, it exactly matches, so I can just pass it on through. And what happened was I say, oh, you didn't have that value, and I passed that value in using the casting trick for enums we talked about earlier. And I passed that value in. He didn't check it in his code, so it went right through to Win32, and I was able to access those resources. So it's a great security boundary because it's just a blanket coverage. If you do the argument validation and make sure that every value in that enum, that the value passed in matches one of the values in that enum, then you're covered. Okay. All right. So just like I need to tell you, but this is kind of how you do argument checking. Okay, so let's spend a couple of minutes doing these. Let's just work on these together, maybe. So a collection class needs a member to return the number of elements in a collection. Do I use a method, a property, an event? A property. Why is a property a good idea? Why is a property a good idea? Yeah, it's like a logical member of a collection. You think about count being part of the collection. What if my collection was a linked list and a strict linked list? And in order to generate the count, I actually had to do a order in operation and kind of walk the entire list. Yeah, that could potentially take a while. With a 10,000 element linked list, that might take a while. So in that case, you might want to say, maybe property is not such a good idea. Okay, how about you need a class that expresses a user ID, password, and a connection string, and in some way to initiate the connection. What combination of methods and properties would you? No ideas? So because the order is important here, what I would do is I can set the user ID, password, and connection string in any order I want to. So I would make those things properties and then have another method that called connect. So maybe I'd have one class that have those three things in it, and then another method somewhere that takes that class as an argument. So I can set it up in any order, and then I call a connect method. Just one idea there. Okay, so let's go through this class. What's wrong with this? Let's just start at the top and work our way down. Yeah, so we got the retirement age thing as an underscore. Any other problems on this line? Yeah, it shouldn't be constant. I hate to break it to you guys, but I don't think the retirement age is going to stay 60. Is it even 60 right now? Yeah, it's probably going to move up. So I don't think leaving that a const is a good idea. How about this next line? Yeah, it should be a property. There's really no reason to make it a field there. And this method? Well, okay, so one suggestion is get name with capital N. Any other suggestions? Yeah, well, okay, maybe that thing should be a property altogether. Just property with a getter, a property called name with just a getter. And how about this indexer here? Say again? Yeah, class is kind of a bizarre name for a class, isn't it? Class. Okay, so that's kind of weird. What else? He's saying that the course number really the thing you want to index by? I mean, yeah, it's an int, but I'm not sure. I think course number is what you might look up. Maybe some lookup thing rather than a indexer. You think of indexers as being contiguous, and course number just doesn't seem to flow right there. And then these last three, these register, this register family is so the first problem with this family of register ones is some take the class name and some take the course number. It depends on what exactly the relationship there is, but that may not. You may need to separate those out into different things. And then the default here around true, I mean, the default we talked about should be false. So false should be the, so you might want to change bool waitlist to don't waitlist or, something like that. Okay, so we only talked really briefly about formatting, so I'm just going to skip this guy here. So what's wrong with this convert? Say again. Yeah, why are we not using overloads? Why do we have int and double there? These feel like semantically the same thing. And then the other thing I'll add is if you have to use the names, the int and double, if you end up having no other choice and you have to use them, then you need to use the kind of CLS names, int32, double, the names we use in the BCL rather than some language-specific names. Because int is a C# keyword. The VB guys are going int. What's an int? I know what an integer is. So you end up having to make it equally bad for everybody and use the BCL names. So it would be best to avoid having to have that problem altogether. Okay, so we talked about all the different kinds, the constructor's method, properties, and events, and when to use them. So we're a little bit over, but why don't we take just a couple of questions on this while it's still fresh in people's minds? Any kind of questions that I had to delay as we were going through? Yeah.
We're talking about the advantages of properties over public fields.
Yeah.
All those arguments apply to protected as well.
Yes, they do. So he's saying his comment was, how about protected fields? Are they okay? And all my arguments for public fields apply to protected fields as well. I try not to differentiate a lot between protected and public. I mean, there's kind of a difference in terms of subclassing, whatever, but they're both part of your public API exposure. Anything else? Any other questions, comments? Yeah.
His advice that API should enforce proper usage. For example, two properties must be always set. That puts them to construct and provide only that construct.
Yeah, it's a fair question. You're saying if the property must be set, should I force it in the constructor or let it be in the properties? Well, I guess the first thing I would say is try not to have musts. Musts are really hard. Is there no meaningful default you can give that thing? So try hard to come up with some meaningful default, but if you can't, like for security reasons or something like that, then I guess it's a hard place, but I might agree with you and put it in the constructor and not have it, not only have the property. Anything else? Okay, well we're running a little bit behind, so let's press on here to the next section.